Hello. Welcome to Tuesday afternoon of Tableau's customer conference in beautiful San Diego, California. This session is all that stands between you and an afternoon nap. How much untapped, unused geographic and quasi-geographic data do you have? If you're in this room, you either have a lot or you're completely lost. By the way, my friends Dan and Wilson are teaching the advanced table calculations class next door, so if anybody needs to sneak out, feel free. Hi, I'm Eric Joyce, product consultant here at Tableau Software. This is my partner, Stephanie Stanfield. She's a business consultant. We're here to lead you on a journey deep into the mapping capabilities of Tableau. Our goal is to equip you with the understanding of these features and how to help you leverage them to better see and understand your data. To that end, let's discuss what we'll be discussing today and what we won't. So, before we start here, you should have a good understanding of the basics of Tableau's mapping capabilities. So you should know that Tableau can make maps and the basics of the geography, what kinds of things you can display on maps, how to navigate, how to fix unmapped locations, and that sort of thing. So just as an overall sort of thing, does everybody have a pretty good handle on that? Okay, great. So let's talk about what we are going to be going through today. We'll start off with sort of leveraging the basics of mapping in a few new ways to leverage that. We'll get into some geocoding issues. We'll talk about backgrounds and base maps. We'll talk about map geometry, and then we'll get into some really, really advanced things with distance calculations and even some animation. So it should be a really great session. We'll get our hands in there, get a little bit dirty, and should be able to hopefully get you all geared up for really taking this back and making some use of it with your own data. So let's start off talking about combination maps. Everybody here has built presumably some filled maps and some point maps within Tableau. We're going to show you a little bit about how to work with that data and how to maybe lay some dimensional data underneath for a little extra context with point maps. We'll also show you another little trick. So let's jump into Tableau. And we'll start off. So here we have the sample Superstore data set. And so you've all seen this where we'll just double click in Tableau, generate a map. We might actually layer, let's do this, let's layer some regional data. We'll turn this into a filled map. So now we have a little bit of context for some information for some other information. Let's actually, we'll prepare this one. This is going to be our background. So what we'll do here is, with that in mind, we'll take the transparency down a little ways. Maybe we'll add a border. And then we're going to add another map. So what we can do is take another copy of latitude, drag it up to the row shelf, and now we have two maps. If we click here in the upper right corner of the marks card, we can select multiple mark types, and this allows us to control both maps independently. So what we're going to do is actually change the bottom map by adding sales to the size shelf. And then we're going to take profit to color and change this back to automatic. And now you've seen this map. We're going to actually turn labels off here. And then maybe we'll actually even add a little more information. So we're going to actually add some detail here and maybe bring zip code in. We'll size these up a little bit so that you can see them better. That might be a little bit. So now, once we've got this information, let's actually lay one on top of the other. We click here, select the dual axis option. Now we've generated a map where, as you can see, we hover, we get both the regional and state information, and then we can actually hover over the individual marks and see the zip code. We could change that out and maybe make it city instead. I might actually clean this up just a bit. Maybe not. But we can see that it's actually Bozeman, Montana. You could actually even have both of those. So we're adding some contextual information to the map. And one thing I wanted to point out, though, is that oftentimes people will have one map. Actually, it would normally. So notice that if I hover over this, I still get the Montana. And what we've got here is the latitude. Now, if we try and click on any one of these individual marks, we're just getting the state, basically because the point map is underneath. So to correct that, if you run into this sort of problem, it's just a matter of reversing the two cells up on the row shelf, and we can select just fine. Any questions about that? Okay, great. So let's jump back over to the PowerPoint. And so we're going to actually go through an exercise here right now where we'll build this and we'll build out a map like this, and we'll actually make some use of that, some use of these techniques along with some dashboarding to build a complete view and to build a complete dashboard and actually have it be interactive with other charts. So then they go on and do their exercise. Okay, so the exercise we'll be doing today will be to build this. You all have workbooks on the laptops that will give you step-by-step guidance as to how to build that, and Steph and I will be up here to help work through these if you get stuck, so please flag us. Putting on to the next tab, back to the correct thing. So let's talk a little bit about geocoding. So you're aware that Tableau comes with a lot of information built into it about geography, so countries, cities, states, that sort of thing, and worldwide data. But it doesn't come with everything. So we have the ability to either add in things that don't come with Tableau geographically speaking. So things like voting districts in France might be one example, or obviously we're not going to have access to your distribution plant locations and retail outlets and that sort of thing. So from a business perspective, there's a lot of data out there that is, as I said earlier, quasi-geographic. It's things that mean something to you, but don't necessarily show up in something that the larger, the wider world would understand. So Tableau gives you a lot of flexibility in adding that kind of information into your current, into your current, and integrating with your current data. So the kinds of things you can do are to, again, to add new geographic roles. You can add hierarchies, and you can extend existing data. You can extend the new locations into existing data. The kinds of things you'll need will be, first of all, there's a lot of good online documentation with Tableau to talk about it. But essentially, what you're going to need is a CSV file with at least one unique identifier. It can contain other information, so plant names or smaller city names or whatever it's going to be, airport codes, that sort of thing. And of course, most importantly, latitudes and longitudes. Optionally, we're not going to get into this too deeply today, but I wanted to mention there's a schema ini file. That's actually a Microsoft file that actually will help define the data types within a file to make sure that numbers are numbers and text is text, that sort of thing. And there's actually some resources online at Microsoft's website that you can make use of to dig a little deeper into that. So let's show you an example of a schema ini file here. Of course, I should have this up already. So essentially, what you've got is what you can see here is that we've actually got the unique identifier is actually this column, the ISO region, but you've also got the actual airport names here. And as you can see, you've got latitude and longitude. So this is an example of what it would look like. There's actually a simpler, there we go. So let me show you a little bit about how this works with a simple example. I've got these two columns here. So we've got some states and we've got some cities. You might notice that there's some information here that's misspelled. So let's bounce back over to Tableau for a second. And what we'll do is make use of one of my favorite little features in Tableau, the paste data. So notice that Tableau took that information and just stuck it right into Tableau. And it already built this little hierarchy of state and city. And then it's just showing you a view of the data that we found there. So we'll go ahead and clear this sheet. And again, just doing a sample map, we'll double click on state. Notice that we've got a couple unknown here. Let's add city into this. Now we've got 5 unknown. Well, let's take a look. So everyone's gone through this before. Hopefully you've already seen the edit locations ability. So we've got a couple of things here. So notice that Tableau didn't recognize WASH. That's simply because it's not a standardized abbreviation for the state of Washington. So we can actually tell Tableau what to do with it whenever it sees WASH. So now we can just simply type Washington, select that. Same thing with Wyoming. And we'll select that. I'll come back over to city, and now we've still got a few unrecognized here. Well, everybody knows, presumably you've heard of Aspen, Colorado. Aspen's a famous place, but it's also below our 15,000 population minimum threshold for ending up in geocoding. So we can actually fix that, and you might have noticed back over here, I actually cheated and wrote them down. So we can actually tell Tableau specifically where these things are. Grab this one, and then Tableau actually gives you the ability to add latitude and longitude. Paste this here. Paste that there. And then you could do the same thing with Carnation, Ketchum. We can actually correct Spokane. Notice again, spelling error here. Spokane. Okay. And then, so now, notice now we've got Laramie, Wyoming has popped up. Aspen, Colorado is now right there, right where it belongs. We still have these 2 unknowns. You can either continue to go through and fix these, or you can, as necessary, just filter them out. So let me show you one other thing that's just another bit about the way mapping works with geocoding and how this sort of hierarchical information works. If I take state off, Tableau will give me, I've got 2 unknown here. I'm sorry, I don't actually have my my example. I'll have a better example actually built in. So anyway, we'll pretend I made the point I was going to make there.
Can you just say the place?
Yeah, the idea, sorry. The idea being that you can use a bit of geographic information in your data set to help define, help further clarify another bit of geographic data set. So, for instance, if you had the city of Portland, there's a Portland, Maine, and a Portland, Oregon. So if you've got both of those, but you've only put city out there, Tableau will consider that ambiguous, and it'll actually tell you so. So if you bring state into the level of detail, then Tableau will actually know, okay, well, this is the Portland, Oregon, and this is Portland, Maine. Pretty straightforward stuff there. So some of the best practices around custom geocoding are to make sure that your data is nice and clean. Ideally, you wouldn't have things like that, the abbreviation being a 3-letter instead of a 2-letter or 4 letters and that sort of thing. Make sure that the data types are accurate. You definitely want to make sure that, that latitudes and longitudes are treated as numeric data and not string data. One of the things that you can do pretty easily is actually just connect directly to the CSV file, just to see if Tableau's recognizing it correctly and kind of what shape the data is in. If you've been using Tableau for a while, you've probably just used it as an investigative tool to look at your data and to see, where there might be holes in it, where you might have nulls or other types of invalid data. And then, again, getting back to that schema ini file to make sure that the data types are enforced. And then, honestly, one of the great ways of actually collecting this information as you go on throughout your job is to store these things in a common directory just so that you have access to, to airport custom geocoding, or, in this case, we have some other types of custom geocoding files. And just to make sure that they're someplace where you can find them all in one spot. So now let's dive into exercise 2, where we'll actually go ahead and map some cities around the country and work through, doing your own geocoding and just working through that with Google Maps.
Okay, I'm Steph Stanfield, and I'm a senior business consultant on Tableau's professional services team. And I have a background in GIS, which is Geographic Information Systems. I've been a developer and system integrator for many years. And so I have a slightly different take on this. And we're hoping that the combined perspective from Eric's experience with numerous Tableau customers and Tableau functionality, and my more recent experience with the world of spatial data and databases can come together here and be really useful for you. What I'd like to talk about with background and base maps are the two types of raster imagery or pixel-based imagery that Tableau supports. We work with web mapping services, both our built-in Tableau maps. We'll review those. And then we also offer the ability for you to tap into publicly available WMSs, web mapping services, or even build your own based on certain specifications. And you can do that using open source software. Your organization may already use ESRI software, and you can definitely leverage other tools to build these web mapping services. For example, a group may want to look at police beats and crime data for the larger Los Angeles area. An environmental group might be tracking white wolves and the different incidents between wolf and human interaction in Wyoming. It could be a really diverse range of data that you want to look at. And so in that case, having custom base maps in the background can be of great use when you're using your data in an analytical way. Background images are a completely different beast. And I think some of you have probably seen some background images, whether or not you've played with them yourself. That enables us to bring in truly quasi-map data or pseudo-map data and to look at latitude and longitude as an X and Y value. So let's go ahead and talk about these types of data. Map service basics. Tableau maps are installed with Tableau, and then when you use maps in the background, just as Eric displayed with the combo map that we started with, that would be using map services coming from the internet. So if you were in a highly secure environment or you were offline out in the deep Alaskan wilderness, for example, you would still have on your laptop some basic mapping capabilities. However, if you are connected online to the servers that support Tableau mapping, you're able to zoom in to far greater detail and see many more options when it comes to demographics or additional map layers, as you see with map options and map settings. So, for example, this picture here is an example of a single tile, single image. This is a PNG image. And when you are using a map service, whether or not it's Tableau Maps online, which is just a basic mapping you can start off with in Tableau Desktop, or whether you're consuming a WMS, the call you make is going to say, hey, I'm looking at a part of the planet. It's going to be a window with the coordinates marked for each of the corners of that window. And then the map service is going to return images, these PNG images, that tile together, that mosaic together to give you a full map for those extents. The closer you zoom in, the more the tiles are replaced by other tiles that have more detail or are a different size. So I just want to give you an idea that here we're not seeing individual points on an outline of the coast. This has all been flattened into a picture of a map, and that's how map services work. To use a custom WMS, you would actually go to the map menu in Tableau, and we'll look at this together. You go to background map, and here you can see in the upper part of the first screenshot here, number 1, that we have the option to have no maps, offline maps, which are those built-in but reduced detail maps, and then online maps. Below the separator there in the menu, you can see it says WMS servers, and this is where you can add custom WMS servers by URL. Down in numbers 2 and 3, you can see an example of adding a URL, saying OK. The name is already derived as part of the URL details, so metadata and WMS server capabilities are going to be passed back to identify what you're looking at. Protocols will be checked and verified. So it's a little more intelligent than just a pure URL as in going to a website. If you look at number 3 here, you can see that we've got a few extra options. We've got none, offline, online. Those are the default Tableau map services. We also have something called eTopo1 Hillshade and another called NowCoast Off WMS. These names may seem quite strange, but they are the default names that were assigned by the creators and publishers of these map services. And we would encourage you to play with some of the WMS services that are available from public, especially federal authors such as NASA, NOAA, and some of the other larger data providers. The USGS is a great one if you're in North America, and often universities and private commercial firms will publish out WMS services that anyone can consume. So what we want to do is look at some of these in a workbook. So let's go ahead and open up some WMS examples. Okay. So what I've done here is if you look at our map, background map settings, you can see that I've added in a whole selection, diverse selection of publicly available WMS services. And we're going to include the URLs to these in the slides, and you'll be able to look at them later and try them out with your own data. The other thing you can do when you're setting up a WMS server of your own is decide which layers are available, such as here on the side, and those can be turned on and off by using the checkboxes. Let's go ahead and look at some of the different WMS services that are publicly available. Remember, these are being fed over the internet. Different tiles are being called and returned, and then depending over here in which of the layers I choose, it's going to take a while to redraw this. So we are not going to do a lot of work all at the same time with these map options. Just extend this. This particular WMS has a huge number of layers. You're going to have to play around with it to investigate the public WMSs available, see which of the layers are really useful. In this case, we are using the blue marble data from the Terra Modis system. So this is all coming in from NASA's basic blue marble data collection from the satellite package, where they refine data and they provide it as a set of tools available for public consumption. We have other versions. Here you can see NASA's NEO system dialed in to display permafrost. You can see here, instead of something that looks pseudo-photographic, they've actually classified this into bands of land cover based on permafrost depth in this case. So again, we're going to be looking at the available layers. You can see there's sea surface and land surface details. We've got carbon monoxide and chlorophyll readings, cloud refraction, global temperature, huge amounts of detail. And in this case, we're displaying known permafrost coverage by depth. So just to reiterate, loads of detail for some of these public services. You will need to follow through and decide which are the most useful for what you're working with. Here's another. This points out that not all WMSs are beautiful, set up to be beautiful. Sometimes it's just about the data. So in this case, we're looking at point observations near real-time surface and land surface and sea surface temperatures for specific locations. And to add in coastal detail, we have to go ahead and work through this layer list and choose specific layers that can show us what we want to see. This is a WMS from the World Health Organization. Again, they've got information on completely different and very detailed facts in their databases. World influenza, malaria distribution, and they also have details on medical clinics and hospital locations worldwide. Here's a commercial group that actually sells services. This is bathymetry information. Bathymetry is about the ocean floor, the bottom of the oceans, and the topography found there. These points on top of the WMS are simply from our global cities data set. So this is an idea of how you can take completely different base map image and background, custom something that you found, something that you built yourself, and then add your descriptive analytical data on top of it to get better context. Here we have information on active forest fires, state boundaries, and I'm just going to leave you with one last point. These services, when you start using them, don't always cover the entire planet. So here you can see we've got cities from Tableau's data that are for the entire world, but we also have a couple of different WMS layers showing, and in this case, there's one that's only good for North America, there's another that's only working for the Americas, and it doesn't have any context for Asia and Russia and Australia. So make sure you look at coverage as well when you're shopping around for some extra base map options. Okay. Let's move on to background images. Background images work similarly to our map data, but it's a bit strange because we can look at things like teeth. And what we're able to do is take an XY location instead of that geographic lat-long location and then link it to data in a business table or a non-spatial table. So here are some examples of visits that Tableau has published out and that Tableau users have created that use background images. And we have a hands-on exercise that's going to let you build out some points on a background image and connect it to data and learn how to customize these yourself. So let's switch over to that hands-on exercise. Okay, coming back to map geometry. We talked about raster data, backgrounds and base maps, those WMS and background images. Those are raster images. We're using JPEGs, PNGs, all kinds of image files that you might find, whether they're map data or non-map data. These come in and they're stretched or displayed in the background behind your marks that are coming in from Tableau chart types. Now, we also offer the ability to bring in custom geometry. And some of you may have seen the knowledge base articles on Tableau or have worked to bring in your own point data, possibly importing custom polygons. If you work with shape files or other geospatial data in a geospatial database, whether that be PostGIS or SQL Server or Oracle Spatial. I know DU2 has a proprietary spatial data format. We can now use certain schemas to transform your data so that it can be consumed in Tableau and blended with other information. So this enables all kinds of very complex, compounded ways to add your data to different levels of integrated visualization. And we're going to quickly cover some of those options here. With point data, we have a single point with a latitude and longitude. I'm going to give you an example here, and then we're going to look at the data schemas behind it. In this case, we're going to say that one point for one of these hurricanes There's a latitude and longitude, and it has a value and it has a time and date stamp associated with it. So some of you have seen this hurricane example. We're going to be building this out together in a few minutes. Here you can see that there are completely different ways of using custom geometry, whether it's a very fine scale in a particular building, in this case a sports stadium. You can also use this for asset management systems if you want to track, for example, server health on a floor plan. And we can also work with larger maps, in this case French administrative departments, excuse my accent, which you can add it in to give you additional detail for managing data in a country of France below the regions, below the different divisions that Tableau has built in. So in this case, one further level down, and you could use this to display everything from household income to type of cheese. Let's go ahead, before we get into the exercise, and quickly look at an example of how custom geometry works at a schema level. Don't be nervous when I talk about schemas. That simply indicates a tabular or database format, a structure that needs to be met in order to execute the business process. So in this case, and we're going to make sure, of course, you have these files to use later, we're looking at the difference between flat space, which is the XY geometry that we all learned in school, and then geometry that's mapped out against the curvature of the Earth. And there's a lot of very complex math when it comes into geospatial geometry. But just think about it. Instead of using XY, we're going to be using a longitude and latitude. You're still going to have two values to define any given point. There are a few little notes down here. You can go into those later. Let's go ahead and jump through and talk about point lines and polygons. Point data is the simplest type of vector data, meaning it's an explicit, defined location on the Earth's surface. You have a latitude and longitude. It doesn't matter how fast or far you zoom in, where you go. This is a single location, mapped to a single ID. Everything else is extra. So in this case, we have in our table, which could be a CSV file, an Excel file, this can detail the depth of your orchestrational database. We have a unique ID. We have an optional place name in this case, a descriptive place name, either of these could work, numerical or a text ID. And then we have a latitude and a longitude. And you can see that in Seattle, we have Tableau's headquarters here in the Fremont neighborhood. We have a burger joint that staff like to go to for lunch. And then down to the south, closer to the downtown, we have Famous Space Needle. So simply 3 locations. It's really that simple. To make lines, all we need to do is to join those together. In this case, we have a unique ID for every single stop, every single point. Here's the latitude and longitude per row, per record, for every single stop. I've added a ridership number, which is just an arbitrary measure to indicate how we can display data. And let's go ahead and look at what this looks like on a map. So in this case, you can see that we've taken points, and by putting them together in Tableau in a certain way, having the route colored and having the place name defined the path, having the marks type set to line, we can go ahead and see different lines, different routes. This could be you riding your bus or bicycle to work. This could be an official bus route or delivery route, and then you can go ahead and display them however you like. If we add points on top, we've created a combo map, just like Mark started off with in the first exercise. So here we've got points on top of lines using a dual axis map, and the points have been sized to indicate that rider number that I've used. Obviously, we've got explicit directions here, and the original data will be handed out. We'll build this together. One step further, let's talk about polygons. Here we've got a polygon ID. For each polygon, we have vertices. Those are the points that define the edge of a polygon. In this case, I've got polygon 1 with 4 points. Always having to start with 0. Polygon 2, again starting with 0. And in this case, very, very simple. This is as simple as you can get with a polygon. Mapping those as points gives you 0, 1, 2, and 3. But if you change the way the marks pane is set up, they turn into polygons. And here's a quick idea of how polygons work. So again, point 0, point 1, point 2, and point 3. And the way they're defined by polygon type, give you very simple polygons. Now we can do the same thing, but we can import polygon data, again, from your database or from another system. We're going to include some knowledge-based URLs, so some tips on how to import data properly, depending on which system it's coming from or what file type you're using. And the results there can be slightly not simple. In this case, this is slightly more sophisticated, right? We're saying that Washington, Oregon might be a sales area called Northwest. And here, California is actually going to be 2 sales areas. So the challenge is to start with county geometry and to go ahead and group those counties into larger polygons and prep them for use in Tableau. So you may have something that you work with where this is going to be an analog to the challenge you face in custom geometry building. And it's definitely something we can help you with. Again, back to front, and this is definitely a more sophisticated situation. In this case, you would have to have the explicit geometry for every single polygon, and you have to make sure that there weren't gaps and overlaps between them. We've gone ahead and set this up with URL actions and some additional tooltip modifications. But again, we'll give you the data and we'll help you to build this out. And I would encourage you to start thinking about ways you can leverage this functionality with your own data among departments at your firm or for future projects you may be working on by yourself or with your team.